Number 7 is also a rational function. It's a little more complicated, but you just have 1 in the top and x's in the bottom. I've given you more x values to fill out in the table here. So you can just start by plugging those in. When you plug in -4, you get 1 over -6 times -3 gives you 1 over 18. You plug in -2, you get 1 over -4 times -1, which gives you positive 1 over 4. When you try to plug in -1, you get 1 over -3 times 0. And so that gives you 1 over 0. And we don't divide by 0 again. So we get a vertical asymptote at x equals -1. And probably you could look at it and guess where the other vertical asymptote will happen here. Can you see what other value for x will make that denominator equal to 0? If you plug in x equals 2, then you get 1 over 0 times 3. And of course 1 over 0 doesn't exist. So you get another vertical asymptote there at x equals 2. For all the others besides x equals -1 and x equals 2, you can find the values. Just takes a second to calculate those. And then once we've got all those values, we'll go ahead and sketch a graph. The x's go from -4 to 4. The y's are tiny, and they're all positive. So I will scale the y's from 0 to 1. I'll make 1 really big. That way I can get those fractions in there easily. And then I'll start plotting the points. I'll go ahead and sketch those vertical asymptotes. And then we'll see if we can figure out how to connect the dots with the right curves. So one thing that I want to point out here is that as x gets really, really big, so as you go out to the right on the x-axis, you're going to be plugging in bigger and bigger numbers. So let's pick x equals 100. If you plug in x equals 100, you get 1 divided by 98 times 101. So that's 1 divided by a big number. If you take 1 divided by a big number, you get a really tiny number. So as x gets bigger and bigger, you're doing 1 divided by bigger and bigger numbers. So your y value is getting smaller and smaller. So we already know as you go far out to the right, your y values are going to be positive, but they're going to be shrinking down to 0. So we can guess what's going to happen to the right of that vertical asymptote here at x equals 2. If you plug in big negative numbers, like -100, then you get 1 over -102 times -99. And the two negatives in the denominator cancel each other out. So you get 1 over a positive number, but it's 1 over a big positive number. So it's that y value is a tiny positive number. And as you let x continue to go out to the left on the x-axis, so bigger and bigger negative x values, those y values continue to shrink down to 0, but they stay positive. So we can tell what's happening as you go out to the left as well. Now there, I can't tell for sure exactly what's happening in the middle there between the two asymptotes and then off to the right. So I'm going to pick a couple of x values that we haven't chosen yet. I picked x equals 1/2 and x equals 3. And you can see when I plug those in, well, when I plug in x equals 1/2, I get 1 over -3/2 times +3/2, which is 1 over 9/4. Negative is 1 over -9/4. It gives me -4/9. And -4/9 is a little bit bigger a little bit above in this picture negative 1/2, because negative 4/8 would be negative 1/2. So negative 4/9 is a little bit smaller number, but it's negative, so it pushes it up the y-axis. And then at x equals 3, we just get 1/4. So that just helps us to figure out what the curve is doing here for sure. And like I said before, it shrinks down to 0 as you go out to the right, but it will always be positive. The y values will always be positive there on the right. And then in the middle, since we plugged in x equals 1/2 and we got a y value bigger than the 2 right next to it, that tells me, based on those y values and based on experience with these vertical asymptotes, that it's going to make that curve. So we can finish the graph up.